So what we can see on the screen here is a 4-spot gribble, and this animal is about 2 millimeters long. So these animals have specialised on living on a diet of wood. They're marine wood borers. We're interested in them because they have an unusual mechanism for digesting wood. The gribble is really interesting in terms of industrial biotechnology. One of the aims that we have in the near future is to be able to make fuels, biofuels, out of materials which don't normally go into the food chain, like wood, things that normally end up on a rubbish dump, for example. And what we're after is means of converting those materials that we know are potentially rich in sugars into sugars that you can ferment, and to do that we've got to digest them. We're interested in this animal because of the fact it's got a sterile gut. We know that it has to digest the wood just using enzymes that it produces itself. And what we see in there is that there are a lot of enzymes that are associated with converting complex polysaccharides into sugars. Digesting wood just with enzymes is really hard. There's a lot of people in industry and in science who are trying to do just that at the moment.
We think that the enzymes that I'm working on pre-treat the wood to allow the other enzymes, the glycosol hydrolases, to break down those complex polysaccharide sugars into simple sugars that the gribble can use for food. Yeah, it is very special. It's the only animal that we know of that can digest wood by itself in this way. It's important to research these enzymes because so far in industry no one has come up with a viable, simple way of doing this. And people who study other animals like termites or cows even, they haven't found a way to do it either because they rely on thousands of different species of bacteria and fungi, whilst gribble does it itself.
So the apparatus behind me here, this is, I almost think of this as a bit of the industrial equivalent of the gribble gut. This is just a demonstration scale, of course this is nowhere near the industrial scale, but this machine here is the place where we would digest the wood into the sugars that we can ferment. And to do that we need to use extremely high temperatures and high pressures in order to blow the structure of the wood open so that enzymes can work on it. And that's analogous in some ways to what we think that the gribble is doing.
Gribble hopefully will show us how we can do this in a simple 1 or 2 enzyme step perhaps that would allow access to these complex polysaccharides. We know that it must be able to do it because all it eats is wood, so if it can do it we should be able to transplant this into an industrial setting where we can use it to our benefit.
So we can't make more fuel out of food, we know that. So we need to go to the materials that we produce in agriculture, which are not food materials, and that's the woody bits of crops like straw, it's wood waste, and it's also the woody biomass from dedicated biomass crops that we can grow on marginal lands where we have little impact on food production or on biodiversity. So the end point of all of this research is that using what we learn from the gribble, we can lower the costs of the pre-treatment, of the production of the sugars from the woody biomass, so we can then have cheaper sugars that we can ferment to produce cheaper and better biofuels for our transportation systems. This is a really good example of where BBSRC investment in fundamental science is underpinning our move towards sustainable industrial biotechnology. We're understanding the mechanisms of digestion in the gribble, we're starting to understand the structure of some of the enzymes that are involved in all of that process, and now we can see how we can take some of that knowledge and move it into this whole context of producing more sustainable biofuels.